Okay. Remember, terms are separated by plus or minus. If there's no plus or minus, that means it's one term, right? You add up the exponents. You might want to write that there. Add up the exponents to get the degree. What's the degree of the first term, my friends? 9. Ninth. Bless you, bless you. 9th degree. Bless you to the second. Mary, darn you. That was a good one. It was good.
What does it even mean?
Okay, Liv. How many terms are in 2? So 1 or 2? Bless you. Okay, wait a minute. That's the second double sneeze. I'm nervous.
The 4th degree.
You gotta add those two together.
Depends if they're being multiplied or
Yeah,
added.
we adding or multiplying?
I think we're adding.
I say we're adding, so you don't. It's x squared. It sneezes squared.
X squared plus y squared.
Okay, guys, Liv is right. It's one term. So you guys write those in there. 1, 1. Those are the exponents. So what's my degree here? 7th. Guys, do not miss these. I think they're free points. Now, number 3 has 9. There is no variable. It's a constant. What's my degree? And I'll give you a hint. It's not 1. What is it?
0.
Zetato. 0. 0.
It's Italian.
All right, Mr. Westfall. Oh, now. How many terms are here? 3. Okay, you want to add the biggest, find the biggest one. That's your degree of this trinomial. 4, 5, 1. What's the highest one? 5. This is a 5th degree. Don't miss those. Don't miss those. You guys try 5. I believe there are 3 terms here, Dorian, right?
Yeah.
Dorian, what's the degree of this first grouping?
10.
What's the degree of this?
9.
9. What's the degree of this?
1.
What's the highest one, obviously?
10.
Guys, this is a 10th. That's a 10th degree.
Ew.
Does that make sense? Do you guys see the difference between the plus and the minuses? Okay, find the biggest one compared to like 2, right? 1. That's one term. Is everybody good? What do you guys know about standard form?
Read this, please.
In what? Numbers out front or exponents?
Exponents.
Does everybody agree exponents? Guys, that's all that matters. What's my biggest exponent here? This one. What's my biggest exponent? That's my first term. Okay, you guys finish it. That's my first term. 7x to the 4. It has nothing to do with 7, even because the 7's the biggest coefficient there too, but it has nothing to do with it. Logan, go.
Plus 3x squared minus 4x minus 6.
Guys, here's what matters. 4, 2, 1, 0. Exponents. This is 0 because there's no variable. Okay? Standard form. What's my leading coefficient? It's the number in front of my first term. Okay, you guys try 7.
Bailey. Oh, question or answer?
Answer.
Go for it.
I got negative 6x plus 5x.
Careful. I think you meant. Say it again.
Negative 6. Oh, wait, x to the 6th.
Good.
Plus 5x to the 5th. Minus 2x to the 4th. And the leading coefficient.
What is a leading coefficient?
The number is going to be
The number in front of the leading variable once you put it in standard form, right? So what is it out there?
oh, negative 1.
Negative 1. You guys okay with the leading coefficient being negative 1? All right, go ahead and add or subtract. And what do you think you should do with your answer? Right, in standard form. So I would actually work on these from greatest exponent down to the least. That way, as I simplify them, they're placed into standard form. All right, Makana, what'd you get?
Negative 13 r to the 6th.
All right, let's take a look at this. They're being added or subtracted, right? Right. So what if I gave you a new problem, and I said, what's 15x minus 28x? What would you tell me?
Negative 13x.
Right. Because when we're adding or subtracting, the powers don't change, right?
Oh, 3.
So it's going to stay r to the 3rd. Okay. Does that make sense now? Then we have negative 10r minus 9r. So Makana, what's that?
Negative 19.
Negative 19r. And is that in standard form? Yeah, we're good. Make sense? Please ask if you're confused. All right, try the next one. And just to save you some frustration, should I be distributing anything here? Distributing.
No.
We only distribute if there's what operation between multiplication.
Am I going to change any exponents here? No. What, 50?
Oh yeah? Nice. Oh yeah.
Yes.
What's 9x squared? Should I add negative 4x squared or subtract?
Subtract.
I guess I should have asked that differently.
Oh.
I'm not subtracting a negative, right? I'm adding a negative.
Yeah, you could do negative 4 plus 9.
Yeah. So what do you get?
I get 5x2 x squared. Or, yeah, x squared.
Which one is it?
X squared.
X squared. Good. Then we move on to the x's. 5x a negative 7x, what do we get?
Subtracted by 2x.
Minus 2x. And we got negative 3 plus 9, which is
Plus 6.
good. Is that in standard form?
Yes.
It is. Did you guys get that as your final?
That's what.
Yes.
Was you busy last night at the Super Bowl? You busy?
A lot of pizzas.
I thought you were making pizzas all day.
He's gonna go off on a Sunday.
No, pizza. It's not his nature. He is kind of saucy though.
Oh, that was a cheesy joke.
Oh.
All right,
They should pay to have us as teachers.
we should.
You do.
No,
Yeah,
you guys don't.
Yes.
Yes.
Why?
That was quite the reaction for a person off their cell phone ring around.
Really?
Yeah.
Where did
All right. Anybody want to volunteer to give us a process here? Zachary.
So you do 6x to the third minus x to the third.
Yeah. You know what I would do? I'll be honest. You're right. You're good. I think you're on the right track. I would probably take a minute and distribute this -1 to all three terms. Okay? Here's what that looks like. Is anything going to get changed in the first set of parentheses by that negative? No. This first set of parentheses does not get changed. But when you subtract a 3-term polynomial, every term gets made opposite. So here's what's going to happen. I'm going to leave this 6x to the third minus x squared. And go ahead, Zachary. When you distribute a -1, you get minus
X to the third.
Yep.
Minus 8 squared.
x
X
squared. Yep. And then
Plus 9.
minus a -9 becomes plus 9. The parentheses dropped because I've taken care of the distribution.
Guys, do this step. Do this step when you subtract. Not when you add, when you subtract.
Everybody understand that? Leah, you good?
I feel like I've been more confused.
You're more confused now?
Well,
What did you do?
just subtracted by 1. Is that right?
Subtract by 1?
Wait, dude.
All right, let's go ahead and simplify and see what you guys get. Again, I like to write my highest term to lowest term as I'm subtracting. Zachary, keep it going. 6x cubed minus a 1x cubed gives you
5x cubed.
good. A negative x squared minus 8 more x squared makes
Minus 9x squared.
good. Plus
9.
9.
Really, all that changes is the 3 terms on the second parenthesis. They change their signs. And then once you change their signs, it's just addition. Just combine like terms like we've done there.
So let's go back to this one, just so you guys can make a little mental note here. Do you agree? Watch up here. All eyes up here. I didn't do it because it's a waste of time, and you would have gotten mad at me even more so than you normally do. Okay. Could I have written a 1 here? Could I have written a 1 here and distributed the 1? What happens when you do 1 times -4x squared?
Same thing.
1 times -7x.
Same thing.
It's a pointless step. Do you agree? We wouldn't do that. But what happens when you distribute a -1? It makes everything opposite side. Do you understand how that's necessary now? Okay? So just be careful there. Go ahead and try this on your own and see if you guys can get this one without help. No.
So do you add after you distribute?
Add or subtract. If it's a negative, you'd subtract. I said you missed it, D.
I didn't even look. I don't even know why I grabbed the key.
Yeah, I didn't usually look at it. I was working on it.
But on quizzes, I noticed that's.
Yeah. Okay. Does anything change here in my first parenthesis, guys? So bring it down. No signs change. Okay, does everybody agree? I'm going to distribute the -1. That's a positive 2y squared now, right? So what's it change to, Bailey? And then how about the -4y? And then what about a +3? Now, once I do that, you just combine them for what signs they are. Okay? What's my highest exponent? I'm gonna put it in standard form. Isn't it y squared, right? Makana? 5y squared minus 2y squared. What do you get?
3y squared.
Real close. I got 3y squared. Keep trying. Okay, how about +9 +4, Makana?
Plus 5y.
Shush. No, you didn't change the sign. It should be +4 now. It's a -4 now, and we're distributing a -1. It turns to +4y. These three things change signs over there in that second parenthesis.
Down to like 9 minus.
It's not mine. It's 9 +4. The minus is gone. Once you distribute the sign and change these things, that's minus sign's gone.
Plus 13.
Does that make sense?
Yeah.
Forget the subtraction sign then. Once you distribute the negative sign, forget your minus and just combine like terms. Okay? Does that make sense? So this will be plus 13y. What's -5 minus 3? There you go. Okay? Come on. Now, everybody go like this. Right now, everybody, come on. We got to change our mindsets. You're not doing it. Nobody. I'll thank you for over there. Thank you. Over here too. Guys, we have to change our mindsets. Now we're multiplying, right? What do we do with our exponents on like variables now? Now we add them. Guys, before we didn't touch the exponents. Now we're changing our mindset. Okay?
Wake up, Jonathan.
Jonathan!
We lost it from He was getting.
Are you back now?
Got really relaxed.
Say what? Yeah, John, that's taking it. Here's the line. Crossed it. I'm just kidding. Guys, now just multiply your numbers together. 7 times 4 in the United States is
28. That's pretty close, but I got
Square.
28. Now, guys, 8 to the 5th, 8 to the 3rd. Add your exponents. 8 to the 8th.
That's right.
Raise your hand.
What about B now, Corbin?
B to 7th.
I'm going to say a strong, firm no.
You're wrong.
8.
Why?
There's a 1 in front of the
Should be B to the 8th.
Whoa, this next one is crazy.
Hey, your mom's crazy.
Whoa.
Whoa, now.
I'm telling her, I'm gonna.
No.
Why are you looking at me?
Because you read.
No, you may not. Okay, listen. That was funny. Hi, Mom. She goes, hi. Okay, listen. Remember that time we called her? Hey. Listen. When you multiply by 1/3, it's like dividing by 3. So what I would do is I would go 6 times 8 and divide by 3. 6 times 8 and divide by 3. If you're multiplying by half, you divide by 2.
Can I ask you guys a question real quick?
Yes.
Because I'm nervous about, like, if we're not up here guiding you, Be honest with me. Does anyone want to do like distributing? Yes?
Yeah.
Okay, do you know why it's not distributing? There's no addition. There's no addition here. Okay? Could I write it like this?
Yes.
Did I get them all? Any Pokemon left?
Did you get the y,
The 8
another y term?
X squared,
Y to the third?
eight, y to the fourth,
Y to the third.
y to the third.
Just do it at the end.
I wanted to put it, the whole purpose was putting together. It's Valentine's Day.
Happy Valentine's Day, guys.
Thanks. I just love this class.
Did you get the 8 of X8?
X to the eighth.
Where?
Do you agree you can multiply in any order? There's no addition here. You can multiply in any order, yes?
Oh, okay.
So we're doing a third times 6 times 8.
What's 48 divided by 3?
16.
Now, x squared times x to the 8th. Just add them up, guys. X to the what? Y to the z to the.
Okay. Don't distribute.
Yes.
Okay? This is not the same as, and I'm only doing this because I'm afraid you're going to make this mistake. This is making what?
I'm confused.
This should not confuse you if you understand it. And that's what happens is we get confused when we're like teetering on the edge of thinking we have it, and then something gets asked of us.
Where did the X come from? Like, for the X.
When you have common bases, you add their exponents. They're not being added, they're being
Is this
multiplied.
not in standard form? Oh, no, it's not.
There's no standard form here. There's
one term.
There's only one term.
Okay.
I think that's what you wanted to do. Aaliyah, what's this?
Addition and subtraction.
It's simplified. This is simplified. This can be simplified more. This is x to the 10th. Here there's multiplication. Here there's addition. Now the tricky thing is you have to know what to do when you multiply bases. You have to add their exponents.
Why is the 16 there?
A third times 8 times 6.
So you're taking the first one.
Everybody, what's a third of 6? 2. Times 8. Or what's 6 times 8? What's a third of 48? Any order, it's multiplication. It's fine. All eyes up here. I'm changing the problem. Are you ready? Do not confuse this with when we did stuff like that. Here there's addition between them. Okay? These are not like terms. This would be simplest form if there's addition between the parentheses. Next thing to keep straight. This is why this stuff can get tricky for some students, because they're not sure. They memorize like a little process, and when it looks similar to something else they've done, they try to just apply it to everything. Okay, so be careful. If I had x squared plus y to the 4th times 6y cubed plus z to the 4th, how is that different? Bailey?
Adding or subtracting something between you distribute
Yes.
x to the
I'm going to pause you right there. You distribute. This is the FOIL process we learned. You multiply x squared and 6y cubed, and you multiply x squared times z to the 4th. Are you all listening? I'm trying to help you. distribute because there's addition between the terms, not between the parentheses, between the terms. And you're multiplying. Do you see how everything up here is just multiplication? Multiply the terms in any order. And since all the numbers can get combined and all the x squareds and x's can get combined and the y's, then you do that. You combine those like terms after you multiply. Do you understand the difference? You should practice those, okay? So how is this different than that? Can I say y times y is y squared because y to the fourth times y to the cubed is y to the seventh? Yeah, but it's because it's part of the distributive property. Good. Go ahead and solve that one on your own.
Yeah.
We're out of time on it.
Sorry.
All right, for the sake of time, when we multiply the first terms, we get y to the second plus outer terms. We get y plus 4y. How about the inner terms? Plus 9y. How about the last terms? Plus only two terms can combine. When they combine, we get 13y or 13y squared? 13y, because you're adding. If I have 4 apples and I add 9 apples, now I have 13 apples. I'm adding. Y squared plus 13y plus 36 in standard form. All right, we're going to have to go through this one together because of time.
You want to post this in?
Yeah.
I'll leave the answer to you here then.
All right, thanks. 5x times 4x is 20 x squared plus 5x times 6, 30x minus 12x minus 18 for a grand total of 20x squared plus 18x minus 18. We're good on that one. Zetri.
Want to be out there.
Next, I double check. Okay, I've got a binomial times a binomial. All eyes up here. All eyes up here. Do you remember the problems earlier that were this? Do you remember that earlier? We didn't FOIL those, did we? We just added. And I said, remember, I can add a 1 and it's the 1's getting distributed. That didn't affect anything, so just add. This is not that. This is multiplication. Multiplication, we have to distribute. What's m times m?
M squared.
M squared minus 7m. We're done with that term. Plus 7m minus 49. What happens to the middle terms? The 7m minus 7m plus 7m. Cancel, we get m squared minus 49, which we kind of expected because this was called the difference of squares. Same terms, one had a plus, one had a minus. They kind of cancel each other out in the middle. But you're going to leave it like that. We're not packing up yet. Next, what does g plus 6 quantity squared tell me to do?
Write it again.
Good. G plus 6 times G plus 6. Do you all agree? And now we have to distribute, which that process with binomials is called FOILing. G squared plus 6G plus another 6G plus 36. G squared plus 12G plus 36. Similar process for this one, 6G minus 7 times 6G minus 7. I get 36G squared minus 42G minus another 42G plus 49. Combine the center terms. And you notice we're writing these in standard form every time. Questions on that one? Am I going too fast? I'll make sure you guys are getting these down. All right. What do I have to do here? There's not two terms over here, so I have to take the 5x and multiply it to all three terms, and then take the -2 and all three terms. What do you get when you multiply a 5x times an x squared? A 5x to the third minus a 35x to the second plus 45x. And then the -2 minus 2x squared, it's a square, plus 14x minus 18. Write it in standard form, so 5x cubed, what's that, minus 37, x squared, 45x and 14x make 59x, and then minus 18. What's the last problem here?
D plus 5.
Is this the last one on your paper?
Yeah.
So what do we have to do here? Write it out 3 times. So D plus 5 times D plus 5 times D plus 5. We're going to FOIL these. And then when we get that trinomial, we're going to simplify it and then distribute the last D plus 5. Okay? I'll finish that video. This is going to get posted today. Make sure you study it. That's a little odd.
Yeah.
You know, wait, I think
Actually,
very odd.
you know who it is. Yeah. He's like, we should hang out. And I was like, no.
At least somebody actually said no.
I was like, I don't know if that's a good idea.
Okay, fair enough.
He's like, that's fair. Right.
Foil, not foil.
Cool. Yeah.
Extra foil.